In this video, I will demonstrate how to use subprocesses, data and forms in DCR graphs. Data simplifies modeling and is more intuitive than having several activities representing data. Representing a yes and no as separate activities is more complicated than having one activity with the values of yes and no. DCR Forms group data events into a form. As a start, let's look at a simple example where we first have to do something. Then we have to make a decision, and depending on the decision, we have to continue with different follow-up activities. The decision is made up of two activities, yes and no, nested in the decision activity. We notice the little n in the lower right corner. We can simulate the graph and we notice that we can redo our decision. First we have to do preparation, then yes, then we have the follow-up is yes, then we can do the no, then we have the follow-up. No. But our activities are not pending. Remember that we distinguish between activities that we must and can do. Activities we must do are marked with the blue exclamation mark. A case or process instance is considered completed once there are no pending activities and we say that the case is accepting. If we add pending to decision, the pending flag is added to both yes and no. Let's try to simulate. As before, we start doing the preparation. Then we have to make a decision, so let's make the yes decision. And as we see, we have the follow-up if yes. If we execute this, we're not done, as we also have to do the no. The process is not completed. So we have to solve this. A way to solve it could be to say whenever we've made a decision, we exclude the decision. Let's try to simulate. First, again, we have to do the preparation, then we do the yes, and then we have the follow-up. The issue now is that we cannot change our mind. So we need another solution. Subprocesses solves this issue. We have therefore changed the decision from nesting into a subprocess. Subprocesses has its own state. We can see it here. This is an example of an included, pending and executed subprocess. We can remove the state, which we see it is now excluded. It has no pending and no executed flag. We re-include to make it sure. So let's simulate this. As before, we start with the preparation and then we have to make a decision which is either yes or no. Once we make a decision, we see that the yes is executed as well as the decision, and we have to do the follow-up if yes. We can still change our mind, we don't have to, but we can change our mind. Then we have a follow-up no to reach an accepting state of the process. Using subprocess as a decision reads that we must make a decision, but we do not have to say which type of decision the user must make. The user must make a decision, but he is free to choose what decision he wishes to make. Instead of having an activity for each decision option like yes and no, we can use data to reflect the type of decision made by the user. We notice that the decision activity has a marking in the upper right corner. This is indicating that this is a data activity. We click the decision activity and the advanced option and notice that the data type is set to choice. We right click on the icon to the right and see that we have set yes to 1 and no to 0. Secondly, we notice that the include and exclude coming out of decision are guarded. The exclude relation is guarded with the expression decision is not 1. Relations with guard are only considered part of the graph if the expression validates to true. So, if decision is 1, we do not consider the exclude relation to exist at all. Even though we both have an include and exclude relation going from decision to follow up if yes, one of the relations are relevant depending on the value of the decision activity. Let's try to simulate this. As before, we start with the preparation. And once we've done preparation, we have to make a decision. Notice now we have to open to make the decision, to cast our vote. Initially, we can say it's yes. When we do that, we see that the follow-up if yes is actually included. We can execute that now, or we can actually also change our mind and reopening the form, casting another vote, and then change the decision, executing that to finalize the process. Guards are controlled by expressions. The formal definition is shown here and can be found at the link below. The expression language supports and, or, less than, greater than, equal, not equal to, and so on. Variables are any activity in the graph. Let's look at the guards again. As we saw before, if the decision was 1, we include the follow-up if yes, as this guard is actually included, evaluates to true. So the point is that a relation only exists if the guard evaluates to true. Let's revisit the example we had before. Just look here at the guards.
The combination of include and exclude rules is a common pattern, so I have decided to create a logical include that combines the include and exclude into one common rule. When the guard evaluates to true, the rule acts like an include, but when it evaluates to false, it acts like an exclude. This simplifies the previous model, as we can reduce the number of rules from 5 into 3 rules. The logical include is simply a shorthand for writing one include and one exclude rule.
Finally, we can group data events into form. We've added 2 data events, a date and a text field, and group them into a DCR form. A DCR form is a transactional subprocess. It has the same semantics as a subprocess, but not considered executed until the form has been submitted. Let's simulate this. As before, we click Start Simulation. First, we have to do the preparation. Then we have to open form of events to make our decision, as well as filling out other data. We make our decision, we can fill out a date, we can write a text, and finally we submit the form. Once we submit the form, the events are executed, leading to follow-up if yes being included. As before, we can actually reopen the form and change our mind, and as well as the values in the form. Once we close or submit the form, the values are again executed and the opposite event is included. We have seen that subprocesses has its own state, avoiding exclude when making a decision. We've seen data in DCR graph, and changing a subprocess with 2 events, yes and no, into a data event with a choice value of yes and no makes it easier. We briefly touched upon expression language and guards, and relations that are guarded are only considered part of the graph if the guard evaluates to true.
We have introduced a new rule, the logical include. It combines one include and one exclude rule and simplifies modeling, as we often see include and exclude in pairs that can now be expressed as one logical include.
Finally, we have seen how we can group data events into DCR forms. Thank you for listening. Learn more about DCR graphs at the links below. Thank you.